Okay, so this video is going to go over lesson 1 from unit 4, solving systems of linear equations graphically, that we're doing on Wednesday, November 18th. All right, so we start off with 2 different Disney scenarios. So your first option is to pay $80 per month and go whenever you would like. Sounds pretty good. Disney option 2 is you only pay on the days that you visit the park, $120 per day. So it's kind of like having like a season pass. These things really exist in real life, having like a annual membership, unlimited access to the park, things like that, like season pass holders, versus just paying on the days you go. So if you choose option 1, how much would you pay for the entire year? Represent this cost graphically on the coordinate plane below. Okay, so option 1 is paying $80 per month. Now we have to think, we're asking about the entire year. So we have to know how many months are in a year. Well, there are 12 months in 1 year. So if it's $80 per month, we would take this 80, multiply by 12 months, and we're going to get $960 per year. Okay. So if you go 0 visits, let me move this down. If you go 0 visits in that year, it's still going to cost you $960. So you know what? I'll make a little table where X is the number of visits and Y is the total cost. So if you go 0 times that year, you're still going to pay $960. What if you visit once that year? You're still going to pay $960. If you go for 2 visits that year, you're still paying $960 and so on. No matter how many times you go, you're just paying that membership fee of $80 per month and you go for however many times you go. So this is going to end up being, let's see, 0, 960, 1, 960, 2, 960. If you haven't noticed already, it's going to be a horizontal line. Okay, so this is the line. Y equals 960. It has a slope of 0. It goes through the point Y, 0, 960. All right, now, if you choose option 2, let's represent this cost graphically on the same coordinate plane. So option 2 is that you only pay on the days you visit the park, $120 per day. Okay, so this was option 1. Now let's take a look at option 2. X is the number of visits, and Y is the total cost. Right, we know that from our axes here. Okay, so in option 2, you're paying $120 per visit. So if you visit 0 times, you're not paying anything. If you visit 1 time, you're paying $120. If you visit 2 times, you're going to pay $240. We're going up by $120 each visit. If you visit 3 times, well, that would be $120 times 3. So that would be, what, $360? If you go 4 times 120, you'd be paying $480. And so on. So let's graph this. So 0 visits, $0. You go 1 time, you pay $120. You go 2 times, you pay $240. You go 3 times, you pay $360, and so on. The price goes up based on the times that you visit. This is like what we typically do when we go to amusement parks, unless you're buying a season pass or something like option 1 was, where it's pay 1 price. Okay, and if we want to write the equation of this line, Our slope is 120 over 1. Our change in y is 120. Our change in x is 1. And it would be plus 0 because we're starting at the origin. Okay, if you choose option 2 instead, represent, okay, we did that. After how many daily visits to Disney World in 1 year will the cost of these two offers be the same? What is knowing this information important to you? So if you see right here, they intersect at the point 8, comma, 960. So what that means is after 8 visits, you kind of break even. You get your money's worth out of that season pass if you go 8 times. So this is really important for you to know. If you're considering buying a season pass, you'd have to go more than, or at least 8 times in order for you to get your money's worth of that pass. If you're only going to go 7 or 6 or 5 times, it's cheaper to just pay per visit. But if you're going to go 9 or 10 times, why would you pay $1,200 when you could just pay $960 and have unlimited access? So, after how many daily visits will the two offers be the same? After 8 daily visits, the two offers are the same. This is useful to determine which is the better deal. I'm going to put which is the better deal for you because it depends on how many times you're going to go. If you're someone who lives right outside Disney and you're going to go like every weekend, then it would make sense for you to get the where you just pay $80 per month. But if you live in New York and you're going to have to fly to Disney, then you should probably just pay per day. Okay. Let's look at the steps. So our key idea, a system of linear equations, is a set of 2 or more linear equations in the same variables. So what we just graphed with those 2 lines that intersected, that was a system of linear equations, where we had 2 different linear equations that intersect at some point. So the solution to the system of linear equations in 2 variables corresponds to the point of intersection. So that's what we're doing right now. We're trying to find the solution to the system, and that's where they intersect, where they cross. Okay, and what that means is that point where they intersect, so in the last one it was a point 8, 960, that point is a solution to both equations. It fits in with the x and y for both equations. Okay, so step 1, you're going to graph the equation. Step 2, you're going to graph the next equation. Step 3 is figure out where they intersect. That's your solution, where they cross. And step 4 is to plug in your solution, your x, y values, into both equations and make sure it fits and is a solution to those equations. Okay, so let's start by graphing the first equation. All right, let me just move this out of the way. Okay, y equals x plus 2. So remember, all equations go y equals mx plus b. So in this case, our m is 1, which is like 1 over 1, and our b is 2. So we're going to begin at 0, 2, and then we're going to move up 1, right 1. Begin at 0, 2. Our slope is 1, so up 1, right 1. Down 1, left 1 if we want to go in reverse. Okay. All right, let me connect those. And I will label it y equals x plus 2. Our other line, y equals 1/2 x plus 4. For this one, our m is 1/2 and our b is 4. So we're going to begin at 0, 4, and then we're going to be going up 1, right 2. So I begin at 0, 4, up 1, right 2, up 1, right 2. up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2, and you should see that they're already crossing somewhere or intersecting. And this is y equals 1/2 x plus 4. So they're intersecting right here at this point 4, 6. So that means that the solution to the equation is 4, 6. So we'll just write that down here. Okay, so now how to check them. So to check this, we're going to rewrite both equations. So y equals x plus 2, and then y equals 1/2 x plus 4. And we're going to plug in our y is 6, and our x is 4, because remember every point goes x comma y. And make sure that it checks. 4 plus 2 is 6, so that point is on that line. Let's see if the point is on this line. So I'm going to plug in my 6 for y, my 4 for x. 1/2 times 4 is going to give me 2, and 2 plus 4 is 6. So it checks. Okay, let's try this one. Our m is 5/6. So we're going to go up 5, right 6. Our b is -2. So we're going to begin at 0, -2. Begin at 0, -2. Up 5, right 6, based on our slope. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's not going to fit, so I'm going to go backwards. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. A slope of 5/6, positive. My line's going upward as I go from left to right, and it starts at -2 because that was our b. Right, and please go back to the videos on how to graph linear equations if you're having a hard time graphing them. Okay, y equals -1/2 x plus 6. So that was for this one. Now let's do this one. Our slope is -1/2. Our b is 6. -1 tells us we're going to go down 1. +2 tells us we're going to go right 2. Our b, our y-intercept being 6, says we're going to begin at 6 on the y-axis. Then we're going to go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And you see they're intersecting. This is y equals -1/2 x plus 6. The solution is where they intersect, which is at the point 6, 3. Our solution to these two equations is 6, 3. To check it, I'm going to rewrite both equations. Y equals 5/6 x minus 2. And then y equals -1/2 x plus 6. Plug in your 6 for your x. Plug in your 3 for your y. And check. You could put this whole thing in your calculator, 5/6 times 6 minus 2. So I'll do that, show that to you. So 5 ABC 6 times 6 minus 2. 3. 3 equals 3. Other side, -1/2. So -1 ABC 2 times 6 plus 6, 3. It checks. That means that point is on both of those lines, which we saw from graphing. Okay, let's try 2 more. All right. Okay, our m is 2/3, our slope. Our b is -6. That means we're going to be going up 2, right 3, and we're going to begin at the point 0, -6. Begin at 0, -6, up 2, right 3, up 2, right 3. 1, 2, 3. Oops, up 2, right 3. Okay. down 2, left 3. Y equals 2/3 x minus 6. Okay, next one. Start at, well, let's do our slope first. Our slope is -2. As a fraction, that would be -2/1. So we're going to be going down to right 1. Our b is 2. So we're going to begin at 0, 2. Down 2, right 1, down 2, right 1, down 2, right 1. And you should see where they're intersecting already. This was the line y equals -2x plus 2, a negative slope. They're intersecting right here at 3, -4. So that means our solution is the point 3, -4. Let's check it by rewriting the two equations. So y equals 2/3 x minus 6 and y equals -2x plus 2. Let's plug in for our x and our y. Our x is 3, so I'm going to do 2/3 times 3 minus 6. Our y is -4. Again, our y is -4. Our x is 3. Let's check this. -2 times 3 is -6. -6 plus 2 is -4. So this one checks. This one, again, you could do the whole thing in your calculator if you want, but I know 2/3 times 3 is just going to give me 2, and 2 minus 6 is -4, so it checks. That point is on both lines. Okay, for the last one, our slope is 3/4, so we're going to go up 3, right 4. Our b is -5, so we're going to begin at the point 0, -5. Begin at 0, -5, and move up 3, right 4. Up 3, right 4. Up 3, right 4. Down 3, left 4. Okay. That was y equals 3/4 x minus 5. And then we're going to graph y equals -2x minus 5. Our m is -2. Our b is -5. So we're going to begin at the point 0, -5. Interesting. They're both beginning at the point 0, -5. But for this one, we're moving down to right 1 because you have to make it a fraction for slope. So you could do your rise over run. So we're going to start at the same point, but we're going down to right 1, down to right 1, up to left 1, up to left 1 to go reverse. Do a little more. And it's obvious where these are intersecting. If they both begin at 0, -5, that's where they're intersecting. So they're intersecting at the y-intercept, 0, -5. And this was y equals -2x minus 5. Okay, so maybe some of you saw that from the beginning. We saw they had the same y-intercept, so you knew that was going to be where they intersect. That's the solution to this system, is the point 0, -5, where they intersect. All right, let's check it. I'm going to rewrite both equations. So we're going to start with 3/4 x minus 5, and then -2x minus 5. Let's plug in our x and our y. We're going to plug in -5 wherever we see y. And then 0 for x. All right, again, you can put this whole thing in your calculator if you want, but I know anything times 0 is 0, so 0 minus 5 is going to give me my -5. Same thing here. Anything times 0 is 0. 0 minus 5 is -5. It checks. That means that point 0, -5 is on both lines. It's a solution to both equations, making it a solution to the system of equations. Looking ahead, will systems of linear equations always have exactly one solution? So all of these intersect at just one spot. They cross once, that's the solution. So start thinking about, is that always going to be the case? Maybe sometimes will they cross more than once or never cross? Think about that. That's what we're going to be doing moving forward. All right, so again, this was the lesson from Wednesday, November 18th, the first lesson in Unit 4 on solving systems of linear equations graphically. Thanks for watching.